Welcome to GER Hub Mathematics and Statistics lessons. Today we are going to be talking about the trace of a matrix. The trace of a matrix. So we want to answer the question, what does the trace of a matrix mean? And in particular, a square matrix. Okay, but before we begin in this video, please subscribe to our YouTube channel for more content and help us grow this channel by doing that for us. Subscribe to the channel, please like our videos, share our videos so that someone out there in need of what we have as our content can actually benefit from it. Thank you very much for all your subscriptions to the channel so far. I am very, very grateful. Please, that being said, let us begin. So, what is the trace of a matrix is where my video on trace of a matrix begins. So I'm going to define what the trace of a matrix is, and then we shall take something more concrete on it. So the trace of a matrix, and I'm putting in bracket square matrix. The trace of a matrix is defined as the sum of its diagonal elements. So the trace of a matrix is simply the sum of the diagonal elements of that matrix. So the trace of a matrix, in particular a square matrix, is defined as the sum of its diagonal elements. Now please take note, the diagonal we are talking about is the principal diagonal of the square matrix. Now in my earlier videos on matrices, I had shown you what the diagonals of a square matrix is, okay? So there are two diagonals in a square matrix. One is called the principal diagonal and the other one is called the auxiliary diagonal. Just to be sure that you remember what we had discussed or had looked at our video, I'm going to put here, for instance, a square matrix A11, A12, A21, and A22. So this is a 2 by 2 square matrix. Now take note, this diagonal in this matrix, there is this element, the topmost left element, and there is this element, the bottommost right element, this one. Now there is a diagonal that runs from the topmost element to the bottommost element, to the bottommost right element, the topmost left element to the bottommost right element. This diagonal is called the principal diagonal. Okay? This is just a quick reminder on what we have done. And there is also another diagonal that runs this way. Now, this diagonal runs from the bottommost left element to the topmost right element, and this diagonal is called the auxiliary diagonal. Okay? So we had done this in our earlier videos on matrices. Please watch our videos on matrices to get more information on this. Now, what we call the trace of a matrix is the sum of these diagonal elements, the principal diagonal elements. So let us take something concrete. Let A be a 2 by 2 square matrix. So it is a 2 by 2 square matrix. Now in that case, we can write A in the general form as A11. Of course, you know that A11 means the element A occupies the first row, first column. A12, the element occupying the first row, second column. A21, that element occupying the second row, first column. And A22, the element occupying the second row, second column. Now, what we call the diagonal of this matrix, or the principal diagonal of this matrix, is this diagonal. Okay? So this is the diagonal of the square matrix. Now, we denote the trace of the matrix. The trace of A is conventionally denoted in either of two ways. So the trace of A, this matrix, is conventionally denoted as TRA, or you may write in full trace of A, full stop. Okay, so if you want to tell us that you want the trace of A, this square matrix, then you can write it either as this TR in bracket A, or this trace in bracket A. Now, what will be the trace of this matrix? According to our definition, the trace of a matrix, in particular a square matrix, is defined as the sum of its diagonal elements. So all we have to do, since I have just told you that this is the diagonal we are talking about, the principal diagonal, then it means that A, trace of A, which can also be written as trace in bracket A, will be equal to A11 plus A12. Okay? Now, if we were to have a matrix, let A 3 by 3 matrix, let A be a 3 by 3 square matrix. So if A were to be a 3 by 3 square matrix, then A can be written as A11, A12, A13. Okay? The elements occupying the first row, but first column, second column, third column. Then we shall have A21, A22, A23. All these are elements occupying the second row, but first column, second column, and third column. Then we shall have A31, A32, and A33. Elements occupying the third row, but first column, second column, third column. Okay? Now, if you were to add this, it will give you this. Do you see it? So all we would have will be this, summing up all the elements along this diagonal. Now look at it carefully. By my definition, I made a mistake here. Okay, so this should be 2, 2, not 1, 2. Now, the trace of a matrix is you adding the elements along the principal diagonal. And in this case, what will the trace be? So the trace of this 3 by 3 matrix will be trace of A, written as trace of A, giving us A11 plus A22 plus A33. Okay, that will be the trace. So all you have to do to get the trace of a matrix is simply to add its principal diagonal element. Now, what about a case that is concrete? Let's take a concrete case. Now let's assume that we are given, for example, to obtain the trace. Example, obtain the trace of the matrix of A, that is A equals 2, 4, 6, 8. The answer is simple. The solution to this problem will be trace of A equals 2 plus 8. Why are we adding 2 plus 8? It is simply because these are the elements along the principal diagonal. So this result will give us 10. So the trace of this matrix is 10. Now if we go to another example, if we were given a matrix B to obtain its trace, obtain the trace of B. And this B is written as 431628150. Now the trace of this matrix as a solution to the problem would simply be obtained by taking TRA equals 4 plus 2 plus 0, which gives 6. Now, how did we obtain the trace? All we had to do was to obtain the sum of these principal diagonal elements. So you have 4, 2, and 0. It is that simple. Now, that being said about the trace of a matrix, let us quickly go to the next thing I want to discuss. there are certain properties that come up as a result of taking the trace. Let us see quickly the properties on the trace of a matrix. Okay, so I'm going to discuss here properties on trace of a matrix. Properties on trace of a matrix. So, what properties are there? Number one, the first property I want to talk about is the trace. Number one, the trace of a sum. The trace of a sum. So, what do we mean by the trace of a sum? Okay, now what this property says is that if you are given the trace of the sum of two matrices, then the result will be the same as the trace of A, the first matrix, plus the trace of the second matrix. Now, I'm going to prove this using algebraic elements. Now, let's assume as proof. Let us assume that we were given let A be a 2 by 2 matrix and B be another 2 by 2 matrix. So let A and B be 2 by 2 matrices. Then note that A will be equal to A11, A12, A21, A22 by what I had explained earlier on. And B can be written as B11, B12, B21, and B22. Now, what by our definition of trace will be the trace of A? So we start with taking the trace of A. The trace of A would be you adding A11 to A22. Okay? This will be the trace of A. And the trace of B will be you adding B11 to B22. So that will give you the trace of B. Now let us add A plus B and thereafter take its trace. If you add A to B, you would have this A11, A12 plus A21, A22. If you remember what we had discussed on addition of matrices, how do you add matrices? You add elements occupying corresponding positions. So for us to get the trace of this of A plus B, we must add A to B. What is the addition? The addition will give you A11 plus B11, of course, because they are occupying the same position. Then you would have here A12 plus B12, okay? Because they occupy the same position. Then this would add to this. Of course, we have added this and we have added this. This will add to this to give you A21 plus B21. And this will add to give you A22 plus B22. Now, is the proof over? We have not finished with the proof. So all we have done successfully is getting A plus B, okay? So I'm going to keep this result handy. Let's see. Now, having obtained A plus B, let us now take the trace of A plus B. So the trace of A plus B will be you adding, excuse me, so it will be you adding A11, this element, to this element. Take note, in the new matrix, this is now the principal diagonal. And along the principal diagonal, you have A11 plus B11 in bracket plus A22 plus B22. Now you can see that this can be arranged by taking the A's, and this will give you A11 plus A22. You can rearrange, and this will give you B11 plus B22. And what is this result? This result, if you check, is equal to trace of A plus trace of B, because this defines the trace of A and this defines the trace of B, and that proves what we were given. Now, having done that for property 1, let us now go to property 2. Now, for property 2, the second property I want us to take is the property that defines the trace of a scalar. The trace of a scalar product or a scalar multiple or whichever way you want to put it, the trace of a scalar. Now, whenever a scalar multiplies a matrix, what will be the trace of that result? So this property says the trace of a scalar alpha multiplying A is the same as alpha times the trace of A. So that is what we want to prove. So I'm going to write here proof. Let's see. Again, I'm going to use a 2 by 2 matrix. So let A be a 2 by 2 matrix. If A is a 2 by 2 matrix, let us see what will be I'm going to put here let alpha be a constant or a scalar. Okay, now it means that A can be written as A11, A12, A21, A22, like we did earlier on, from which will follow that Ka or alpha A in this case will be equal to alpha times A11, A12, A21, and A22. Now, if you remember or have watched our videos, if you have watched our videos on scalar multiple, then you would come to realize that the result of multiplying a scalar by a matrix is that of multiplying each element in the matrix by a scalar. So this will be alpha A11, alpha times A12, and then alpha times A21, and finally alpha times A22. Now, let us take the trace of this result. Let us take the trace of this result. This result is the result alpha A. Now, if you take the trace of alpha A, let's take the trace of alpha A. Okay, so let us take the trace of alpha A. The trace of alpha A will be equal to the trace of this matrix. Alpha A11, alpha A12, alpha A21, alpha A22. Okay, and that will be equal to the result of adding these. So what would that be? It will be alpha A11 plus alpha A22. If you factorize by bringing out alpha, you would end up having alpha times A11 plus A22. Okay, and that gives you this. Now, what is this? What result have we obtained in the bracket here? You would note that this result A11 plus A22 is the trace of A. So this establishes the property 2, that the trace of a scalar multiplying a matrix is equal to the scalar multiplying the trace of A. Now that proves property 2. So let us go to the next property. I'm going to call property 3. Now, what is property 3 saying? Property 3 talks about the trace of a linear combination. Okay, so the trace of a linear combination. Trace of a linear combination. So we want to state what this means and also prove it. So the trace of a linear combination, let's say alpha A plus beta B. Okay, alpha A plus beta B, the trace of this linear combination will be what? So all we have to do is trace of alpha A is alpha trace of A plus beta trace of B. Okay, so we want to prove this. Again, we shall use a 2 by 2 matrix. So the proof. Now let A be a 2 by 2 matrix. Let B also be a 2 by 2 matrix. Okay, now what is the trace of A? So the trace of A, in this case, take note again, A is A11, A12, A21, A22, and B is B11, B12, B21, B22. Okay, so the trace of A, or the trace of alpha A plus beta B is what we want. This will be taking the trace of alpha A. Now take note, the trace of alpha A, we don't know. Let's go over to alpha times the trace of A. What would the result give us? It will be alpha in bracket the trace of A. The trace of A, remember, is this. So I'm going to write alpha times the trace of A, which is A11 plus A22. Okay? Then what is beta times the trace of B? Beta times the trace of B is beta in bracket B11 plus B22. Okay? Now, we are going to add alpha A, first of all, to beta B. When you do that, what are you going to have? You are going to have alpha in bracket A11, A12, A21, A22 added to beta in bracket B11, B12, B21, B22. Okay? Now, if we continue, we are going to obtain the next result. The next result to this, if we continue, will be, let me put this a little bit here, and this will give us alpha A11, okay? Alpha times A12, alpha multiplying A21, alpha A21, alpha multiplying A22 to give alpha A22, plus, now beta multiplies B11 to give you beta B11, beta B12, beta B21, and beta B22, okay? Now, when you add these two matrices, what would you have? You end up having alpha A11 plus beta B11, okay? That is adding this element to this element. Adding this element to this one, because they occupy similar positions, of course, will give you alpha A12 plus beta B12. Now, if you add this element to this, it will give you alpha A21 plus beta B21. And if you add this to this, because you occupy similar positions, of course, it will give you alpha A22 plus beta B22. Now, what would that give you? Finally, for you to get the trace of this matrix, you would have to add this diagonal, okay? So adding the elements of the principal diagonal will give you alpha A11 plus beta B11 in one bracket plus alpha A22 plus beta B22. Now, if you take like terms, what I'm going to call like terms in this case, this would add to this would add to this, and this would add to this, okay? So this adds to this, and this adds to this. And the result you have finally is alpha A11 plus alpha A22 in one bracket plus beta B11 plus beta B22. Now, what is common to both sides is alpha. So if you bring alpha from these two terms, it will give you A11 plus A22 in bracket times alpha. If you bring beta from this bracket, you end up having beta B11 plus B22. And take note, alpha is brought out. What would this give you? This will give you the trace of A. And if you bring out this also, you will notice that would also give you the trace of B. And that proves that particular property. Now, the next property I want us to go to is the property of product. Now, please watch our videos on the product of matrices, okay? So let us see. Now, the trace, I'm going to write here, this is the fourth property. So the trace of products. Now, when you multiply two matrices, A and B, then the trace of AB is equal to the trace of BA. So let's see. Now I'm going to use a 2 by 2 matrix to prove this also. So let A and B be 2 by 2 matrices. Okay? Let A and B be 2 by 2 matrices. So I'm going to write A as A11, A12, A21, A22. And I'm going to write B as B11, B12, B21, B22. Okay? Now, if you multiply A by B, it will give you, this will give you, using this, use the elements of the first row to multiply the elements in the columns, okay, of B. So this will be A11. Using the first row to multiply the first row, you end up having A11 times B11, and I'm going to write that result here, A11, B11. Then plus B12 times B21 will give us A12 times B21 will give us this times this, B21. I'll close that bracket. Then I'm going to use this first row again to multiply the second column, and that will give us A11 times B12. This gives us A11, B12 plus A12 times B22, and that gives us this. Okay? Close the bracket. Then when you are done with using the first row to multiply, you will now come over to using the second row to multiply these columns in B. That will give you A21 times B11, that is this times this, plus A22 times B21. Okay? And that gives you that. Now, coming over to using the second row to multiply the second column, that will give you A21 times B12 plus A22 times B22. So, when you do that, we end up multiplying this matrix. Now, what will be the trace? Take note, this is the same as writing AB. So, AB is the same thing as writing A times B. Now, what will be the trace of AB, which is A times B? The trace will be you adding this, the principal diagonal element. And what would that give us? It will give us A11, B11 plus A12, B21 in one bracket plus A21, B12 plus A22 times B22, close bracket. So that will be the result you obtain. Now let's hold on to this result and go over to using or to getting B times A. So I'm going to use the red pen for B times A. B times A can be written as BA. So what is B times A? In B times A, we are going to bring the matrix B forward. B11, B12, B21, B22. And we will use that to multiply the matrix A, A11, A12, A21, A22. Okay? Now let's see if that property is true. Now when you multiply, what would you obtain? The same procedure is repeated. We would use this to multiply this and this. That is the first column of this matrix will multiply, the first row of this matrix will multiply the first column and second column respectively. So let's start with using it to multiply this. B11 times A11 will give you A11, B11, okay? Plus B12 times B21 will give us A21, B12. Then come over to this place. Use this first row to multiply this, the second column. You will have B11 times A12 will give you A12, B11 plus B12 times A22 will give you A22, B12. And that ends that. Then come over to the next, using this one, the second row to multiply this and then this. B21 will multiply A11 and that will give you A11, B21 plus B22 will multiply A21 and that will give you A21, B22. Okay? Then come over to the last. B21 will multiply A12 and that will give you A12, B21. I'm bringing A first in every case forward before B. B22 times A22 will give you A22, B22. Now, what will be the trace of this? What will be the trace of this? What will be the trace of this? Now, let me take this forward. So the trace of this will then be, obtaining the result this. That is adding this, okay? trace of BA will be equal to A11 B11 plus A21 B12 in one bracket plus A12 B21 plus A22 B22. Now, comparing both of them, you would notice they are the same. I could rearrange this result by saying A11 B11, that is this plus this, in one bracket A12 B21, and that will give me a rearranged result. Then I can add this to give us plus A21 B12 plus A22 B22, and that will give us the result we earlier obtained. This is the same result we obtained for trace of AB, and that proves the property. Okay, so you look at it again. That is what I want to show you. Then the last property I'm going to be looking at is the trace of just a matrix with one element. Now that is property 5, trace of a one element matrix. Trace of a one element matrix. So this property says the trace of a one element matrix is the element itself. Is the trace of a one element matrix is property number 5. The property says the trace of a one element matrix is the trace itself, or the element itself. The element itself. Okay, the trace of a one element matrix is the element itself. So let us do this. Let A be a 1 by 1 matrix. Then what will A be? A will be equal to A1 1, and that's all. Now what is the trace? What is the trace of A? The trace of A, written as TRA, will be equal to A11 itself, and that proves it. Okay, so the trace of a matrix is the sum of its diagonal elements, and the only diagonal in this matrix is this one, so this is A11. Okay, now the final thing which summarizes this video on trace of a matrix is what I want to describe now. So to summarize, let A be an M by M square matrix. Then the trace of A is equal to the sum, is equal to the trace of A, let me put it this way, is equal to the sum of the principal diagonal elements of A. Okay, and this means that if we write A, the n by n matrix, to be A11, A12, A13 up to A1m. Okay, then for the second row, A21, A22, A23 up to A2m. Then it goes down to AM1, AM2, AM3 up to AMM. Okay, now this is a square matrix, so if you want to obtain the trace of A, to summarize this video, will be A11 plus A22 plus A33 plus it goes on up to AKK. Okay, and that can be written using summation as the sum from I equals 1 to K, or to M in this case. Let me put here M because I'm using MM, so this will be to M of the matrix, of the matrix element AII. Okay, so this is simply what we define to be the trace of a matrix. The trace of a matrix is the sum of its principal diagonal elements. So this is what we have for this matrix. Thank you very much for watching this video. Thank you for your likes to our videos. Thank you for your subscription so far. Just in case you haven't subscribed to the channel, please subscribe to our channel for more content and updates on more content. Thank you very much. Please subscribe. I'll see you in a bit.